linear algebra. So we are still in systems of equations and their solutions. We've learned how to solve things with graphing. We've learned how to solve things with substitution, and we've learned how to solve things with elimination. Now we're going to review that just one time before we move into, I think the next lesson is, let me look. Still 17. So when I do a song and a dance. Linear inequality. So lesson 18 is going to be all about inequalities, where these are equalities. All right? Okay, so let's jump in. Let's find out how many solutions a system of equations could have. Here's a hint. It's one. Just one. Andre is trying to solve this system of equations. Looking at the first equation, he thought the solution to the system is a pair of numbers that add up to 1. I wonder which two numbers they are. Choose any two numbers that add up to 3. Let the first one be the x value and the second one be the y value. Let's do 1 plus 2 equals 3. The pair of values you choose is a solution to the first equation. That's true. That is a solution to the first equation. Check if it is also a solution to the second equation. All right, so 4 times 1 equals 12 minus 4 times 2. 4 equals 12 minus 8 is 4. Yes. This is honestly when I should erase and start over, or like rewind and start over. Okay, let's try another solution. So 1 and 2 did work. I just want to prove something. Let's try 0 and 3. 0 plus 3 is 3. So let's try it. 4 times 0 equals 12 times 3. 12 minus 12 times 3. Let's start that over. 12 minus 4 times 3. Ooh, 0 equals 12 minus 12, which is in fact 0. So 0 and 3 works. 1 and 2 works. I bet 2 and 1 is going to work. I bet 3 and 0 is going to work. Okay, so pause for a brief discussion with your group. Well, you're my group, and you don't talk back to me when I talk to you. So, how many solutions does this system have? Use what you know about equations or about solving systems to show that you are right. Well, this system actually has infinitely many solutions, and there's a very important reason about that, okay? I know I just did the hint, it's just 1 a few minutes ago, but this system right here has infinitely many solutions. And there is a very specific reason why. So systems of the solutions have infinitely many solutions, no solutions, or one solution. Okay, those are your options, and we'll talk about why. I left a piece of slide in here that was blank in case I needed to write more. I'm learning. I'm getting smarter. All right, so here. A recreation center is offering special prices on its pool passes and gym memberships for the summer. On the first day of the offering, a family paid $96 for 4 pool passes and 2 gym memberships. Later that day, an individual bought a pool pass for herself, a pool pass for a friend, and 1 gym membership. She paid $72. Hold on a second. I'm actually going to check something about that last part. Again, I'm going to go back and do one more thing with that last lesson. And if we were live in the classroom, I would be rewinding here too. Let me rewrite these. X plus y equals 3. 4x equals 12 minus 4y. Now this second equation, I'm going to rearrange it so it's in the right order of the first equation. So if I add 4y to both sides, I get 4x plus 4y equals 12. Now if you just look at this equation and this equation, what do you notice and wonder? If we do 4 times this first equation, we get 4x plus 4y equals 12. They're the same equation, okay? This equation and this equation are the same equation. So this equation and this equation are the same equation. So there are infinitely many solutions because if we graphed those, they would be on the same line, okay? Okay, let's move on. All right, so we have just read all this. Now it says write a system of equations that represents the relationships between the pool passes, gym memberships, and the costs. Okay, so I need a new slide, which I gave myself a new slide here too, because I need more space. But I've got all this written down here, just like you have all this written down on yours. All right, so we know that we have pool passes, first day, $96. So that's equals $96 for 4 pool passes and 2 gym memberships, where I have to say P equals the cost. We'll do price for a pool pass, and G equals the price or the cost for the gym membership. Now let's keep reading. Later that day, an individual bought a pool pass for themselves. So 1 pool pass, a pass for a friend, 2 pool passes, and 1 gym membership, and paid $72. So I actually don't like how I wrote that. So I'm going to gather my like terms and write 2P plus G equals 72. Okay? So that is my system of equations. Okay, find the price of a pool pass and the price of a gym membership by solving the system algebraically. Explain or show your reasoning. So I can either do substitution or elimination. I'm going to do elimination and go ahead and multiply this second equation by -2. All right, here we go. So I'm going to rewrite this one in purple, -4p plus -2g equals -144. And then I'm going to rewrite that first equation so they're lined up. And add them together. Well, that cancels. That cancels. We get 48. 96 minus 144, 48. -48 equals 0, which is not true, which means there is no solution. When both of your variables cancel out and you're left with 2 things that don't equal each other, you have no solution to that system of equations. Right? So we solved by elimination, and this leads to a false equation. I can say that right there is false, therefore, no solution. Use graphing technology to graph the equations in the system. All right, so let's go over to the graph. For x plus 2y equals 96. X is pool, y is gym, and 2x plus y equals 72. All right, let's zoom out. What do we notice about this system of equations? You're right, they're parallel, all right? They're parallel, which means their slopes are exactly the same thing, which means they will never cross. Back when you learned about parallel lines in elementary school or middle school or junior high, you learned that they're like train tracks and they never cross. Train tracks never cross or the train car would fall off of them. Okay, so they are parallel. Parallel lines don't intersect. The lines have the exact same slope, but different y-intercepts. Okay, your y-intercepts are different, but the slopes are exactly the same. Okay, all right, let's go back to the textbook. So you should write that down. Parallel, same slopes, different y-intercepts. All right, parallel, not spelled right. Same slopes, different y-intercept. All right, how can we tell from the graphs that there are no solutions? They don't intersect. The intersection of two lines is their solution, and these two lines don't intersect. How can we tell for sure that the lines are parallel and never intersect? We could find their slopes. Which is the change in y over the change in x. Okay? If we did that for this one, the slope would be -2. Okay? So slopes are the same, but the y-intercepts are different. That's important. The y-intercepts are different. And the slopes are equal. Very important. It has to be y-intercepts are different, slopes are equal. Those two things have to be a part of it. Why do parallel lines mean no solutions? Because they never intersect. And the intersections are the solutions. The intersection is the solution. It's not plural. All right. What does no solutions mean in this situation in terms of price of pool passes and gym memberships? The price for the pool passes and for the gym memberships are different for the two purchases. Maybe the second purchase, they got a deal. Maybe the first purchase, they got a deal because it was the first day, first come, first serve. Maybe it was an age thing. If you're younger, it's cheaper. I don't know. But and for this one, the prices for a pool pass and for a gym membership are different for the two purchases. Okay. Okay, now this right here is going to be a card sort. Each card contains a system of equations. Sort the systems into 3 groups based on the number of solutions each system has. Be prepared to explain how you know where each system belongs. We're going to do this in class. Okay, I've got the card sorts going and laminating, and everyone's going to get their own set, and it'll be fun. All right, and this is going to be your card sort. There's lots of them, all right, but it's going to be really cool. I'll get that ready for you. Okay, so let's try to put together what we know. So here's an equation. Create a second equation that would make a system of equations with one solution. Let's see. I'm going to change this into, I'm going to isolate y, solve for y. So 5x to both sides. That gives me -2y equals -5x plus 10. And divide everything by -2. Divide by -2, divide by -2, divide by -2. So I get y equals positive 5/2 because negative divided by negative is positive, minus 5. So my y-intercept is -5, my slope is 5/2. And we call the y-intercept b and the slope m. For some reason, I don't know. All right, so we want one with one solution. All I need to do is write an equation with a different slope. I don't care what it is. We're going to make it 3x. And it could have the same y-intercept. Okay, it honestly could. Let's do plus 4. All right, let me write these down so that I can graph them. Y equals 5 halves x minus 5, and y equals 3x plus 4. Let's go graph. Y equals 5 halves, x minus 5. Let's go home. And y equals, it does not matter, 3x plus 4. Oh, bad choice on my part. The solution is way down here. It's there though. Okay, it's there. Negative 18 comma negative 50 is the solution to this system of equations. Negative 18 comma negative 50. Blah. Okay, not my best system. Okay, no solutions. All right, no solutions means that they are the exact same line. They just look different. Class is over. So I'm going to go ahead and do this. So multiply this first equation by 4. And I'll get 4y equals 4 times 5 is 20, x minus 20. Now let's go graph this. Let me write it down. 4y equals x minus 20. Delete that one. Go back to home. So 4y equals minus 20. All right, if we see, these are the exact same line. So that one is incorrect. You weren't expecting me to say that, were you? This is infinitely many solutions. Okay, infinitely many solutions. Okay, no solution means I need something with the exact same slope and different y-intercept, like I told you. Y equals 5 halves x minus 2. Okay. Come on in, I'm just finishing something. So 5 halves x minus 2. Oops, that was 5. 5 halves x minus 2. And the 4 has to go away. Home. Oh, ha. Like, where'd the other graph go? Okay, so we see here we have two lines that are parallel. Exact same slope, different y-intercept, and they will never intersect. Okay, that's where there is no solution, all right? So this red one would be no solution. Same slope, different y-intercept. Where infinitely many solutions is they're technically the same line. All right. All right, a system with, we can fill this out. What does it mean for a system to have one, no, many solutions? Okay, we're going to pass this out. I'm going to do a handout in class. Okay, what are some characteristics of the equations, graphs, solutions? Okay, so we'll hand this out in class when we're together. All right, so we did what we were supposed to do today, got our learning targets, and we have all of these vocabulary words, and they are fantastic. All right, good job. We will see you in class.